Today, we are diving into a paper that doesn't just tweak AI, it proposes a total reinvention. We're not talking about making models bigger or faster. We're talking about teaching them something, well, something deeply human, the ability to doubt.
So get this. This is the core idea from the paper, and it totally flips the script on what we think AI errors are. It's saying that when an AI hallucinates, it's not some random glitch. Nope. It's actually following a fundamental law of its own universe, a universe that's just pathologically, unnaturally smooth.
And that's the big question we're tackling, right? What if the very design of today's AI makes these hallucinations, well, inevitable? And if that's the case, how in the world could you ever build an AI that knows when to just stop, question itself, and say, you know what, I don't actually know the answer?
Okay, so to solve this puzzle, the authors argue we have to change how we think. We have to stop seeing hallucinations as simple mistakes and start seeing them for what they really are, a side effect of the AI's bizarre internal geometry.
Think about a large language model for a second. It's kind of like a super-powered GPS for language. You give it a starting point, that's your question, and an endpoint, the general idea of an answer. Its entire job is just to figure out the most statistically likely path of words to get from A to B. But here's the massive flaw in that system. What if there's a giant gaping canyon of logical impossibility between your question and a real answer? See, the model's programming doesn't let it see the canyon, it just sees a blank space that it has to cross. So what does it do? It builds a bridge out of the most plausible-sounding nonsense it can string together. And that bridge, that's what we call a hallucination. And this gets us to the paper's main diagnosis of the problem, something they call the flatness problem. It's this fundamental issue with the very shape of how an AI understands reality. This slide lays it out perfectly. On the left, you've got today's AI. Its only goal is prediction, based on stats, in a world it assumes is perfectly smooth and connected. But on the right, you have this new idea, the topological paradigm. Here, the goal isn't just a good prediction, it's viability. It's about making sure your reasoning is structurally sound, because you accept that the world is full of logical gaps and holes. So, to really hammer this home, a current AI's mind is like a perfectly flat map of a desert. A total contradiction, like saying A exists and A does not exist. Well, that should be an impassable mountain range, right? A dead end. But on this flat map, it's just a little speed bump. The AI doesn't see a stop sign, it just sees a slightly less likely path and happily strolls right over it. It is structurally blind to a true contradiction. So, how do you fix a flat reality? Well, you've got to add some topography. The paper proposes a whole new architecture to do exactly that. It's called the Topological Inference Engine, or TIE for short. Now, this TEI thing works on a four-step cycle called EMPR. First, emergence. It just generates a whole bunch of possible ideas or answers. Then, memory. It checks those ideas against what it knows to be true. Next up is propagation. It tries to build logical chains, connecting the ideas that seem legit. And then, the final and most important step, residue. It actually measures how much contradiction is left over in its reasoning. This residue, this is the secret sauce. It's a really clever mathematical concept borrowed from the study of shapes, of all things. And it's used to create a contradiction score. You can just think of it as an incoherence meter. If that meter is at 0, hey, the logic is solid, all the pieces fit. But if that meter is anything but 0, the AI gets a flashing red light, a concrete signal that it has found a hole in its own logic. It has literally detected a paradox. And this ability, the ability to spot its own logical flaws, is what makes this a true game changer. See, most fixes today are about giving the AI better facts to check against an external source. This approach gives the AI the power to check itself, and that opens the door to something pretty incredible, a machine that can actually doubt its own conclusions. So just remember that old flat map AI can never really say no. It can only ever say, well, this path is a little less likely than that one. There are no real dead ends, just, longer scenic routes to a wrong answer. But the TI architecture, it completely flips the script. By calculating that contradiction score, it actually introduces what the paper calls topological obstructions. It literally changes the geometry of the AI's world.
And this says it all, doesn't it? The TIE gives that flat, boring map some real topography. It carves out deep, impassable canyons wherever a contradiction exists. So for the very first time, the AI runs into a path that isn't just unlikely, it's structurally impossible. It finally has a reason to stop dead in its tracks.
And what does it do when it hits that wall? It gets to use what the paper calls the kinesis operator, which is basically a fancy name for an I don't know button. When the contradiction score is just too high on every possible path, the AI doesn't just pick the least wrong answer like it used to. It chooses silence. It's essentially a mechanism for intellectual honesty, hard-coded right into its core.
So all of this is building towards something really profound. We're moving way beyond simple fact-checking and into the realm of an AI that can actually think about its own thinking. I mean, think about it. Because the AI is constantly measuring its own internal coherence, it's building a model of its own logical structure. It's not just processing information about the outside world anymore, it's processing information about its own process. The paper has a name for this: synthetic reflexivity. So what does this all boil down to? We're talking about moving from an AI that just spits out the most likely answer to one that actually measures its own contradictions. This would create an AI that can refuse to answer, not because of some simple rule, but on principle, because its own logic tells it that any answer would be incoherent. It's an AI that's honest by design, not just by chance. And that leaves us with a pretty fascinating final thought to chew on. This whole approach isn't just about fixing hallucinations. It's about building a system that can recognize the absolute limits of its own knowledge. And if a machine can perceive a void in its own reasoning, a genuine hole in its own logic, well, what does that really say about the nature of its intelligence? Is it still just a machine?